Good morning, dear students. Last class we have studied about angles, and this class we are going to study a new part in our chapter. First of all, you have to tell me, I will show some cards and you have to tell the what they are. What is this? A square. What is this? Rectangle. What is this? Circle. What about this one? Is this a rectangle? No. Is this a circle? No. Then what is this? This is a triangle. So we have seen the different what? Square, rectangle, triangle, then square, circle. Yes. What are they? They are some shapes which we know. Yes. So in this part we are going to study about shapes. So that's our chapter today. So we have studied the different types of shapes, but you see there are, see whether these are all same? No. Yes. Whether this square and this is same? No. They are different. So from this what we can identify? There are two types of shapes. Okay. There are two types of shapes. They are 2D shapes and 3D shapes. So what are 2D shapes? So 2D means two dimensions. The shapes which have two dimensions, that is, if it can be laid down on a flat surface, if it is laid down on a flat surface, then that is called 2D shape. If a shape is laid down on a flat surface, then it is called 2D shape. Then what about 3D? 3D means it has the three dimensions. If a shape has three dimensions, then we can call it as a 3D shape. Example, this cube, it is a 3D shape. That is three dimensions means if it is having all the dimensions, that is length, breadth, height, then we can call it as 3D. Okay, so this cube, then cuboid, then cylinder, all those are having three dimensions are called what? They are called 3D shapes. So in this lesson, we are going to study the properties of some 3D objects. Okay. Dear students, now we are going to study the properties of some 3D shapes. Tell me some 3D shapes. Yes. Cube, cuboid, cylinder, then so many shapes are there. Yes. So buildings, all the other things are 3D shapes only. Yes. So now we are going to study the properties of some of the 3D shapes. First we are going to study the properties of a cube. Okay. What are the properties of cube? So first one is cube. See here. So when we see the cube, immediately we can say that all the faces are equal. You see the side of the cube is called face, and immediately we can, while seeing a cube, we can say easily that all the faces are equal. So that is the first property of the cube. All the faces are equal. So all the faces are equal. How many faces are there is the next question. All the faces are equal. So how many faces are there is the next question. How many faces are there? Can you count and tell me? 1, 2, 3, 4, 5, 6. So 6 faces are there. Therefore 6 faces. And these 6 faces are equal to each other. Then these corner points are called the vertices. Okay. So how many vertices we have to count? 1, 2, 3, 4, 5, 6, 7, 8. 8 vertices are there. Therefore 6 faces, 8 vertices. Then here you see these are called the edges. The two vertices joints and the in between that length is called the edges. Okay, so 12 edges are there. Can you count it? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 edges are there. Therefore, we can see that for a cube, all the faces are equal. How many faces? 6 faces. How many vertices? 8 vertices. How many edges? 12 edges. So these are the properties of cube. So next we are going to see the properties of cuboid. So while seeing this, we can say this is a cuboid. Yes, cuboid. So here also there are some properties. While seeing this, we can able to tell something about this cuboid. So that are the properties of cuboid. So we are going to see the properties of cuboid now. Tell me. Cuboid. What about? First of all, about the faces. Here, like cube, we are going to study the faces. What about the faces? Whether all the faces are equal? No, all the faces are not equal. Then how we can say that? How is it? Opposite faces are equal. Very good. Opposite faces are equal. Therefore, in cuboid, opposite faces are equal. Okay. Opposite faces are equal. And how many faces are there? 1, 2, 3, 4, 5, 6. 6 faces are there. How many vertices? How many vertices? 1, 2, 3, 4, 5, 6, 7, 8. 8 vertices are there. Then how many edges are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yes. So 12 edges are there. Therefore, we can say that for cuboid, opposite faces are equal. There are 6 faces, 8 vertices and 12 edges. Now, what are the similarities between cube and cuboid? Can you tell me? 6 faces, 8 vertices and 12 edges. What is the difference between cube and cuboid? In cube, all the faces are equal. But in cuboid, opposite faces are only equal. Are you able to understand, students? Yes. Dear students, next we are going to study the properties of cylinder. Can you tell me some examples for cylinder? Yes. See, I am also having an example for that. See, this is like a cylinder. Yes, and this is also like a cylinder. And this is also like a cylinder. So, we are able to understand how a cylinder is. The cylinder have 2 faces. You see, 1, 2. Here also 1, 2. Here also 1, 2. Yes, so 2 faces are there. These faces for cylinder, we are calling it as base. So, the faces of or the surface at the end of the upper portion and lower portion of the cylinder is called base. So it has 2 bases. For cylinder, it has 2 bases. Okay, and we are able to calculate the height. The distance between the 2 base, that is the upper base and the lower face, is called what? It is the height. So the in cylinder, height can be calculated. It is the, what is height? It is the distance between the upper base and the lower base. Able to understand? Upper base and lower base. So, if we measure the distance between upper base and the lower base, then it is equal to the height of that cylinder. Are you able to understand, students? Next, we are going to study about the properties of sphere. So, this is an example for sphere. Yes. So, when we see the sphere, can you tell how many faces are there? Are you able to tell how many faces? We are unable to tell. Yes, because only one face is covering that the whole surface. So, that is called this face. We are not telling it as face. This is surface. Okay. So, surface is there. In sphere, surface is present. It is the same surface covering through the whole area. Okay, and if I keep a point at the center and if I measure the distance between this center point and the points on the circumference, then I can see that the distance between all the points on the surface and the point on the center will be having the same distance. Okay, that is the distance between all the points on the surface and the central point will be equal. So this is the speciality of this sphere. So in sphere, you see here, if I keep a central point like this, okay, in sphere, central point like this, we can calculate the radius of this sphere, and double the radius is what? If I multiply into, we will get the diameter of the sphere. So I am able to calculate the radius. Also, you see that this central point and meets all the points on the surface, and if I calculate the distance between these point distance between these central points and this center point, I am able to find that all the distance are equal. It is equal to r, this radius distance. Are you able to understand? So this is the speciality of what? Sphere. If I keep a point on the surface and if I find the distance between the point and the central point, I am able to find that the distance is same for all the points on the circumference of this sphere. Okay, all these distances are same and it's equal to what? Distance is equal to r. Okay, distance is equal to the radius of the sphere. So this is the special property of this sphere. I think you may have understand. Yes, thank you. Dear students, next we are going to study the properties of cone. This is also a 3D shape cone. Cone, immediately you will remember what? Seeing a cone. What you will be remembering? Remembering an ice cream. Yes, an ice cream. Remembering an ice cream. So that's an example for this cone. So that ice cream cone, it's a 3D shape. Okay, I am also made a cone, and this is an example of 3D shape. And you see here the shape. For cylinder we are having two bases, but for cone one end is what? Sharpened, and the other end is having a base, and this base is a circle. Base is a circle, so it have a base and this base is a circle. So cone has, what are all the things that cone have? Cone have a one end, it's having a point like this, and we can call this as apex. So cone has apex and a base, and the base, it is a circle, that is circular base is there. Circular base is there. Then what are all the things we are able to calculate? See here, we can keep a point at the center of this base, and we are able to calculate the radius of this base, that is distance between the central point and any point on the circumference of the base will give the radius of this base. Okay, so we are able to calculate the radius, and you can see that in the cone, let this be the cone, and it is having a circular base, and we are able to calculate the radius, and you see this is the apex. From the apex you are keeping the central point now. From inside, if you are drawing a line and if you are finding the length, so this is this finding the length means this length, that is from the apex to the central point of this base, we will get a height, that is the height of this cone, that is the height h of this cone. And if you are calculating the height or distance from this apex to a point on the circumference of the base, that is from the apex to the circumference of this base, like this, if you are finding or measuring the length, then that is called slant height. That is called slant height. Slant height L. So in this cone, this slant height and this height are not equal. So h is not equal to L in cone. So cone, we are again seeing In cone, there's a apex and a base. Base is circular, able to calculate the radius. There is a distance between the central point and the point on the circumference of the base. And then we are able to calculate the height and slant height. This is the special property of cone. We are able to calculate the two heights. One is the actual height of the cone, that is from the apex to the central point of that base. When we are measuring the length, it gives the actual height of the cone. And if you are measuring the length between the apex and the point on the circumference of the base, it will give the slant height and L, and we can see that this height and this slant height are not equal. So this is the special property of cone. So in this class we have seen the properties of some of the 3D shapes. I think all you have understood these portions, and students, if you have any doubt in this, feel free to ask me personally and clear your doubts. And what is your homework is, study the properties of these 3D shapes and write it without seeing. Show your parents, get sign and write your name in that paper or in that page and send me personally. Okay students, thank you.